Okay, these are the last set of notes for the sexual reproduction unit. So you looking at this is actually a review from back when we were in the mitosis unit. So cell differentiation. We know what a cell is, simple unit of life. Differentiation. What's the root word for that? It's different. So this is talking about how do cells in one person's body, how do they become different? We now know everybody, we all started out as a sperm and an egg uniting in fertilization. And how does that one zygote, that one cell, replicate over and over again and become arms, legs, eyeballs, hair, teeth? So we looked at this before again. So, and unfortunately, grammar does count in this particular section. An undifferentiated cell. Un means not. So undifferentiated, big long word, meaning not different. This is a baby cell. And a baby cell still has access to all of its genes. It's a baby. It can grow up and become anything it wants to. During differentiation, or as a cell is differentiating, that is the actual process by which the cell is currently growing up from a baby, from an undifferentiated cell to an adult cell. When it grows up, what's actually happening? Well, you're permanently turning off all of its non-used genes. So, if it is a cell that is inside a mother's womb and the baby is growing inside of her, then one of the cells is going to become an eyeball. So as that cell grows up in the eyeball, it becomes specialized so that it can take images and pass those images on to the brain. No other cell in your body can determine images and provide images to your body. Only eyeball cells can. So during differentiation, and a lot of this, but not all, happens in the womb before we're born, the little baby cells grow up and become adults. So any non-used genes are permanently turned off. They can never be accessed to be used. They are accessed to be replicated in S phase of interphase, but they are not accessed to be used. Now, once a cell is considered a differentiated cell, that means it's an adult. It has finished the growing up process, and now it can only do whatever job it was meant to do. So you have a baby cell, which is an undifferentiated cell. Then you have a cell that is growing up, called a differentiation or differentiating cell. Then when it's become an adult, it's all done. Then you have a differentiated cell. Now, further on in your notes, here's just a picture of how does a zygote develop into a fetus. So this is a big picture. So the first one, you have immature gametes, which actually, that should say diploid number. Immature gametes are diploid, not haploid. Through meiosis, they become mature gametes, which are haploid. Then, in the process of fertilization, a zygote is made. The zygote is diploid. Then, through mitosis, you make a whole bunch of cells. And as that process is occurring, because everybody knows, if you've ever seen a pregnant woman, when she's just 2 or 3 months pregnant, she doesn't really look much pregnant. When she's 8 months pregnant, she's big. So that growth, mitosis continues throughout the entire time in the womb. And then at a certain point, and pretty quickly, some of those cells will start to differentiate. Once enough of those cells have differentiated, you have a fetus. So this is what we all looked like at one time. This is a developing head. These are arms and come popping out. That one and that one. There's some feet somewhere right there, little nub. And yes, there's a little tail. You all had a little tail too. This is a few months after this. You can see the sac. The sac itself is the placental sac. The fluid in here is water. You can now, this over here is the baby's head, but you can now see clearly the skull, the eyes. You can see this black stuff in here is going to become intestines and stomach. You can see a limb right here. There's a little leg over here. So this from here to here is mitosis. You're getting more and more cells, and differentiation. Now, I got a cool video, and we're going to watch that right now.
This is Tyler. Tyler, with Grammarly's help, is writing an email to his boss, Anita.
Okay, here's a video. There's no music, there's no words here, just music. So this is computer generation, what a baby looks like in the womb. This is the zygote. Before you get to the zygote, here are the sperm. They are swimming to find the egg, and they are swimming up the fallopian tubes and the birth canal, the uterus, fallopian tubes, wherever they need to find the egg. The first sperm wins. This is what the inside of the female body reproductive system looks like. And conception, most often, but not always, happens in the fallopian tubes. That's the nucleus from the egg and the sperm just united. So now it is a diploid nucleus. Half the DNA from mama, half of it from daddy. The first mitotic division. Now there's 2 identical cells. Now there's 4 identical cells, and so forth. This is mitosis, not meiosis. Meiosis made the egg and the sperm. This is going to become a baby eventually. It's just a cluster of baby undifferentiated stem cells is all there is there. The red cells in the middle, those are the actual stem cells now. The cells around the outside, those will become skin. So those skin cells do have some, they're in the process of growing up, so they're losing access to their genes as this zygote still is floating down to the uterus to implant itself. It's just more, you don't have to know what ecto and endo and mesoderm are. What? Okay, so that's the first part. And gotta go back in here. Okay, so that shows you just kind of how they grow, and there must be another video somewhere that finishes it up because I thought that one finished it up further. So what we're gonna do is continue on, and here we go. So now when the baby's in the womb, we can actually go in and a mother can get an amniocentesis done, and that takes some of the cells that are floating around in the amniotic fluid, and it does a chromosomal map. So this is actual human chromosomes. Notice how you have different kinds of black, white, and gray banding patterns. They are arranged in size order. Number 1 is always the longest chromosome. And then notice as you go down the numbers, they're getting a little bit shorter and shorter and shorter till you get down to 22 is the shortest. The last pair of chromosomes, this is the sex chromosomes. And this has 2 X's, so this is a baby girl. And here's her picture. And this is Down syndrome. You're supposed to have 2 copies of every chromosome, one from your mom, one from your dad. In this particular situation, something called non-disjunction had occurred. Okay, and we've talked about that in the notes already. So non-disjunction occurred, and that ended up by having 3 copies of chromosome 21. So that gives you the condition Down syndrome. And they do have this very similar facial features. This is actually the diagram that's in your notes. Okay, another problem that can arise is not having an extra chromosome from non-disjunction, but having not enough chromosomes. This part here is in your notes. The picture is not. This person has 2 chromosomes from each parent. They are, like the other one, arranged by size. 22 is the smallest chromosomes. But notice here, your sex chromosome, there's only 1 sex chromosome. So this person is XO. O meaning like a 0 because they don't have one. And this is called Turner syndrome. The default sex in all mammals, is female. This woman, if you happen to watch NCIS LA, which is a show, I believe it's on Sunday nights now, she actually has Turner syndrome. Turner syndrome, they are female, but they're very petite, shorter in stature, very tiny people in general. And a lot of times, a person may not ever know they have the condition until they try to have children. And a lot of times they can't conceive. And then through some checking, they may find out that this was the problem. But this is a female. And so this person does not have 46 chromosomes in all of their cells. This person only has 45. And now, and prior in the notes, you've got some other examples of this, but there with Ms. Zahn. But there's quite a few of these that can happen, which are errors in chromosome number. So too many or too few. And this is called a karyotype, and this is actually what's done when a pregnant woman goes to the doctors and gets an amniocentesis done, and they take a look at those. Now, once you have your baby, congratulations, baby's born. In the organization of life, okay, we all came from a single cell, which is the zygote, uniting of an egg and a sperm. Then we create, in differentiation in the womb, tissues were created. Tissues would be blood tissue, muscle tissue, connective tissue, which connects your skin to your body and your organs to each other, and then brain tissue or neuro tissue. So then you have these little tissues forming, and all tissues of the same kind, they do have access to similar genes because they're from that same tissue. You put a bunch of different tissues together, you get an organ. You put a bunch of different organs together, you get an organ system. So this would be your digestive system. Mouth, stomach, liver, there's your stomach, liver, small intestines is here, large intestines is here, and then the rectum at the end. So that would be your digestive system. And then this yellow thing here, the pancreas does secrete digestive enzymes. Okay? You put the digestive system and the circulatory system and the excretory system. You put all these systems together, you get a whole organism. Okay? So this concludes the rest of the notes. I'm trying to find the video. Oh, the twins. This is always a topic. I'll go ahead and cover this now. There are different types of twins. Fraternal. So these are fraternal twins. One's a guy, one's a girl. Same thing here. Okay. Identical, which are down here. These are fraternal as well. And then you've got the conjoined or Siamese twins. And then you've got monozygal twins. Okay, so let's look. Fraternal twins have different egg, different sperms, have come together to make two separate babies that can be from the same parents, but they have different DNA. Identical twins, which are these two here, they have an egg and a sperm join. You can get identical twins from either side of the family. Fraternal twins are only going to happen from if they're in the female side of the family, because for fraternal twins, the female has to produce 2 eggs in the same month. But identical twins can come from anybody. And what happens with identical twins is once that first single-celled zygote is formed, for some reason, it splits. It does a mitotic division, and it has 2 zygotes. And because they are identical, then they grow up into identical twins. Now, conjoined twins or Siamese twins. These girls, they are, I think, sophomores in college now. They have one torso. Each twin has its own head, her own head. Each twin has control over one side of the body. So one head controls the left arm and the left leg. The other head controls the right arm and the right leg. And this is them up close. They are obviously going to the same college. They do have slightly different majors, which is kind of interesting. And they have to obviously sit through each other's classes. But they only have one torso. And they have their own YouTube channel. They're very popular. And I'm sure you can Google them and find them. These are 2 turtles that are conjoined at the back end. And these are 2 turtles that are just like the twin girls here, where they have one torso and each head controls half of the body. Okay. Here's some more conjoined twins. These 2 are joined at the head. In fact, they each only have one eye. And here's another. This is a different set of conjoined twins, but you can see they're joined at the head and they're joined at the abdomen. These 2 were famous in the circus, and that's a black and white picture because they didn't have color film back then. But they're joined at the torso, and then these 2 babies are joined here at the abdomen. So Siamese or conjoined twins. What happens with them is that they were going to be identical twins, but during the process of cytokinesis, the cytoplasm did not completely divide. So the 2 zygotes remained connected. And even though they're connected, each twin actually developed and the cells differentiated on their own. So you end up by having 2 people that are actually still conjoined. And I was trying to find that other video that we have. Maybe not. Oh, I'm just going to see what this is. Okay, not too impressive. Let me try the other one. There was one I was trying to find that showed the babies developing, and I'm not sure that I have that anymore. I think that they may have taken it off. Yeah. Okay. So, but this one is pretty funny. It's 4 minutes, and I'll post this one separately, okay, to not make the video too long. All right, so that finishes up the notes, and you've got some other work to do.